Hello everyone, welcome to the last minute revision of the linear algebra. Today I will explain you the 100 plus questions how you can solve the linear algebra problems with the help of shortcut tricks. Myself Dr. Harish Garg, you can follow my YouTube channel where you can find the playlist of the CSIR NET. You can see I had uploaded the last minute revision of the CSIR NET real analysis. Apart from them, you can also see the various other lectures, and this playlist is a very helpful for you. You can crack the examinations, and you must subscribe my YouTube channel. Always remember students, whenever you will see the question related to the matrix, try to solve the problem either with the help of the eigenvalues or the rank always. Fine. That will give you the answer in less than of the 15 seconds. How you can solve the problems? You must watch about my these two lectures available in the same playlist so that you can understand the concept. Apart from them, there are the various other lecture also available in the same playlist, and you can learn the concept very well. Hope you can subscribe my YouTube channels firstly. Now let's start with the first question. You can see the reaction of this guy is very funny because the question is very funny. Look at that. The first option is determinant of the m. Can you find the determinant? 1, 1 minus of t square, minus of t, 1 minus 0. So it will be 1 minus t square minus t. So is it a polynomial of degree 3? No. Determinant is 0 for all t? No, because if I choose t is equal to 0, which belongs to the R, determinant is non-zero. Is it 0 for infinitely many t? No, because this equation is my quadratic and it is 0 only for the two values of the t. So how many seconds you are needed to solve the problem? Only the 15 seconds. Look at this another case. Let n is greater than equal to 1, alpha and beta are the real numbers such that alpha is not equal to beta. You can choose any value of the alpha. Let's say alpha is 1, beta is my minus 1. Fine. Suppose an is my n cross n and n must be greater than equal to 2. So I can choose n is my 2. Fine. Then what is your an? What is your an? You can see diagonal entries are alpha, non-diagonal entries are my fine. So can you find the value of the dn? Dn is the determinant of the a2, 2 cross 2. So 1 minus 1, 0. Determinant of the d1, that is only the one element, that is 1. Fine. Now look at the options. This is d2, alpha minus beta. You can find the alpha minus beta is my 2. 2 into 1 plus beta is my minus 1. So clearly say they are not satisfied. Look at this case. Left hand side is 0. This is 1. 2 raised to power 0 plus minus 1, that is satisfied. This is 0. Alpha is my 1. N minus 1. N is my 2. 2 minus 1 is 1. Raised to power 1. Alpha minus, which is no, this is 2. Sorry, it is minus 1. Beta is my minus 1. Beta is my minus 1, which is satisfied. Look at the last case, 0, 1 minus and 2, it is satisfied. So up to the 2, only one option discard. Fine. Now I can choose n is equal to 3. Then your matrix will be diagonal entries are 1 and the rest values are my minus 1. Fine. So can you find the d3? Clearly say the determinant is minus 4. d2. d2 means the determinant of the 2 cross 2, that will be my 0. Fine. So if I start from the last case, this is d3. d3 is my minus 4. Alpha is my 1. N is my 3. 3 minus 1, 2. 2 times of the beta is minus of 2. Alpha minus beta is 2. 3 minus 1. So is it satisfied? Yes, it's satisfied. Look at this one. Minus 4. Alpha is my 1. This is my minus 2 square. Alpha minus 1. So which is not equal. Look at the second case. This is minus 4. 2 raised to power 2, which is 0 plus beta. beta will be, you can see it's a D3, it's a D2. D3 will be my minus 4. So 4, which again satisfied. Fine. So up n is equal to 3, this condition satisfied. N is equal to 2, this condition satisfied. N is equal to 2, both conditions are satisfied. So definitely for the next cases are also satisfied. So B and D are my right answer. There is no need to check more values 4, 5, 6, because if two values are fine, that is more than enough. Okay, look at this third case. A is a matrix. Your target is to find the firstly A star. What is the A star? 1. It is minus of iota, complex conjugates, minus iota 1. Fine. So A star is equal to A, option cancel. A star is equal to A inverse. That means if you that means your target is to prove whether this is I or not. Fine. So can you multiply them? 1 I 1, 1 minus iota 1, whether it's a 1 or not. So you can see 1 minus iota square. The first number will be my 2. The calculation of this will be 2, which is not my identity element. Now, A square. Can you find the A square? 1 iota 1, 1 iota 1. So that will be 1 minus plus iota square. That will be the 0. But we need the identity element. This option cancel. Only the left behind is B is my right answer. Okay, now you can see it's a raised to power 20 and it's a very funny. Your target is to, you can solve this problem with the help of the eigenvalues. Very easy. Can you find the eigenvalues of the matrix A? You can see there are the two ways. Either you can write the A minus lambda I, but always remember if each row has the same sum, say for example K, then K is the eigenvalue. Fine. Now you can see what is the sum of the each row is 1 and 1. So therefore one of the eigenvalue is my 1. Can you find the second eigenvalue? Second eigenvalue I can use the trace. The trace is my 2. So the second eigenvalue is also 1. So these are the eigenvalues of the matrix A. Can you find the eigenvalues of the matrix A20, which is also the 1 and 1? Fine. Now look at the option. If it's a 1 and 1, the sum is not a 1. This is a 1, but this is not a 1. This is not a 1. This is a 1. This is a 1. So that's the B is my right answer of the problem. Okay, again A and B are the two matrices. Your target is to consider whether A is 0, I or minus I. Fine. So let's say if I firstly assume A is equal to B is equal to I, then what is the determinant of A plus B? Determinant of A plus B is a 2I, and it is my 2 cross 2, that will be my 4. So this number will be 4. A minus I will be 0. Determinant of I is 1. Determinant of B is also 1. So which is not satisfied. Second option, this is 4. This is 0. This is 2 minus 2, not satisfied. 4 plus 0, which is 2 plus 2, it may satisfied. 4 minus 0, 2 minus 0. So only left option is C is my right answer. Always consider these three cases, either of the three cases, to get the right answer. A is a 2 cross 2 matrix with a determinant 1 and trace. Can you find the equation of the characteristics equation? That is here. Fine. So that will be lambda square minus 3 lambda plus 1 is 0. Your target is to find the trace of the A square. I can find the eigenvalues of the A, then I can find the eigenvalue of the A square. So can you find the roots of this? Minus B plus minus B square minus 4AC divided by 2A. 3 plus minus 5 over 2. So eigenvalue of the A is 3 plus root 5 over 2, 3 minus root 5 over 2. So can you find the square? So 9 plus 14 plus 6 root 5 by 4 and 14 minus 6 root 5 by 4. So can you find the trace of the a square? The sum of the eigenvalues 28 by 4. 7 is the right answer of the problem. Dear student, don't forget to like and comment on the videos. Okay, if P is the square matrix such that P square is equal to P. What is the square matrix? Size is not given. So let's say it's a 2. So I can assume it's a 2 cross 2 matrix. Well, since the matrix size is not given to you, so I can consider the simplest way is my 2. Fine. So can you think any of the example where P, okay, I can, because it's a matrix, I can solve by the eigenvalues. So it is lambda square minus lambda is 0. So eigenvalues are my 0 and 1. So can you construct the matrix? Is it fine? Now moreover, once the eigenvalues are my 0 and 1, so what is the trace of the matrix? Trace is my 1 because one of the eigenvalue is 0. So the determinant of the matrix is, because it's a 2 and one of the eigenvalue is 0, that means the determinant will be 0. So the rank of the determinant is my 1 because 1 is a non-zero values. So you can see the trace and the rank are same. Fine. Trace is an integer. Yes, you can see the trace is an integer. Trace is an irrational number. That is wrong. Trace is an imaginary complex number. That is wrong. So the right answer of the problem is P square P. That is a B and C are the right answer. Otherwise, if you consider the matrix like of this, fine. Clearly say P square is equal to P. Then what is the rank of the P? 1. Trace of the P? 1. So again you can see the B and C are the right answers. Okay, look at this another one. Again it is related to the, again n is not given to you. So let's say n is my 2. So if A is my 2 cross 2 matrix with the rank 1, what is the meaning of the rank 1? That means the last row will be 0. And what is the eigenvalues of the A? Fine. You have the 2 eigenvalues because the 2 cross 2 rank is 1. So one eigenvalue must be 0. Fine. So that means that second eigenvalue can be any number. So for the sake of convenience, I can choose it is 1. Fine. It has any number, say 3. So the other eigenvalue is my 1. Clear? Now, what are the eigenvalues of the I? 1 and 1. So what is the alpha? What is the eigenvalues of the I plus A? Eigenvalues of the I plus A is 2 and 1. So can you find the determinant of the I plus A? Determinant is the product of the eigenvalue. So alpha is my 2. Beta is my trace of the A. So this is my A. Eigenvalue, sum of the eigenvalues is my this. So therefore alpha is my 2. Beta is my 1. So you can see this option is cancelled. This option is cancelled. Alpha minus beta is 1. Beta minus alpha is wrong. So the right answer of the problem is B is my right answer. Dear students, please like, comment and share this video. Okay, again I can choose n is my 2. Fine. A and B are of the 2 cross 2 matrix. Suppose the sum of the elements in the each row of the A is my 2. Sum of the each element is my 2. So can you construct the matrix? This is my A. Fine. Sum of the elements in the each column is B. So that is B is also same. Fine. Now look at that. So what is the A transpose? A transpose is nothing but A, which is same as B. So if you look about that, this case will be my 1 minus half B square. This value will be I minus half A square. This value will be half I minus half A square. This value will be I minus B square. Fine. Which of the following is necessary singular? That means your target is to find the determinant should be 0. So can you find the eigenvalues of the B? B is equal to A. Each row has a sum 2. So one of the eigenvalues is my 2 because the trace is 2, the other eigenvalue is 0. Fine. So these are the eigenvalues of the B. Can you find the eigenvalue of the B square? This is 4 and 0. Can you find the eigenvalue of the half of B square? It will be by 2 comma 0. Eigenvalue of the I will be 1 comma 1. Now if you subtract them, can you find the eigenvalue of the half B square? It will be 1 and 1, minus 1 and 1. Fine. And clearly say the determinant of the eigen or product of the eigenvalue is the determinant, which is non-zero. Therefore, it is not a singular. First option cancel. Is it fine? Now, look at the similarly, because A is equal to B. So if the first option cancel, the second option automatically cancel. Look at the third case. It is a half. So can you find the eigenvalue of the 1 by 4 B square? 1 by 4 B square is my 1 comma 0. Eigenvalue of the I minus 1 by 4 B square is I has eigenvalue 1 comma 1. So it's a 0 and minus 1. So once you get the 0 eigenvalue, so the determinant will be 0. But based on this, we can't say that this is the correct option. Fine. Now we can consider another example. The sum of the each row is my 2. Fine. B I can choose in such a way the column will be, I can take the transpose of this. Fine, which is nothing but transpose. Now you can see about these options. So what will happen for the last case? I minus 1 over 4. A transpose is B, so that will be B square. Fine. So can you find the eigenvalue of the B? Eigenvalue of the B is my 2 comma 1. Eigenvalue of the B square will be 4 comma 1. Eigenvalue of the 1 over 4 B square will be 1 comma 1 by 4. So eigenvalue of the half 1 minus 1 by 4 is 0, 3 by 4. Again it's a 0, so that means this is my singular. But we can see about the second case. What is the A into B? So I can multiply them A into B. A into B. So that is a 2011, 2101. So that will be 4, 2, 2 and 2. Fine. And then I can divide it by 4. So it will be 1, 1 by 2, 1 by 2, 1 by 2. Fine. And then I can subtract I. So if you subtract them I, the first element will be 0. It is half. It is half. It is half. So clearly say the determinant of this matrix is non-zero. So this option is cancelled. Left behind is the D is my right answer. Look at this another one. A is my 4 cross 4 with eigenvalues. Fine. The trace of this. So can you find the eigenvalues of the B? You can substitute the minus 1 here. It is a 1 minus 5 plus 5. Substitute 1 here. Again 1. Substitute 1. Substitute minus 2. 16. 4. 20 plus 5. It is 1. So trace of A plus B is trace of A plus trace of B. So trace of the A will be minus 1. Trace of B will be 4. So the answer is 3 is my correct answer. Okay, it's a June 23. A is a 3 cross 3 matrix which on the following statement is false. It has a 3 eigenvalues. Fine. Whenever you have the matrix, always think about the eigenvalue. A has a 3 cross, A must have the one real eigenvalues. Definitely correct statement. Why? Because if A is your 3 cross 3 matrix, then what is the characteristics polynomial? Characteristics polynomial is of degree 3, and we all know that every odd polynomial has at least one real root. Fine. So must have a one real root, yes, but we need a false statement. If determinant is 0, then 0 is the eigenvalue. That's obviously correct statement, because if the determinant is 0, that means one eigenvalue is 0. So B option is the correct option, but we need a false statement. If determinant of A is less than 0, 3 is the one of the eigenvalue. So you have the three eigenvalues. One eigenvalue is 3, then A has 3 real eigenvalues. What are the other eigenvalues? Assume that other eigenvalues are A plus B, A plus iota B, A minus iota B. Then determinant is less than 0. Can you find the determinant of this? 3 times A square plus B square, which is less than 0, which is not possible. Whatever the value of the A and B, it can never be less than 0. So that statement is my false statement. Clear? Now look at this next one. If 3 is the eigenvalue, then A has 3 real eigenvalues. Okay, we'll think about the fourth case. If determinant is a positive, then 3, no, sorry. Okay, we will see the firstly fourth case, whether it's a correct or determinant is a positive. That means 3 times A square plus B square is greater than 0 always. Fine. So that means whether A may be the complex number, still determinant is a positive, but it has A has a 3 real eigenvalue. That is a false statement. Because it has a complex eigenvalues, still determinant is less than 0, greater than 0. So that is a false statement. If determinant is less than 0, one of the eigenvalues is 3, A must have 3, A must have, okay. So when it will be possible? It will be possible only, this can never be possible. That means the complex number is not be there. So that means these three eigenvalue, one is the A, second number must be of the minus of the B. So that means yes, all has a must eigenvalue. That's the correct statement, but we need a false statement. So the fourth option is the correct option of the problem. Okay, again is the matrix characteristics polynomial trace. So again try to think about 0, I, minus I. Let's say A. If I consider A is my identity, A inverse is also identity. What does it mean? Characteristics polynomial of the A and characteristics polynomial of the A inverse are same. Then A square is also I, A raised to power 5 is also I. What is the determinant of the A square? 1, which is also equal to the determinant of A5. Determinant of A5, 1, 1. Can you find the trace of the A square? It is a 5 cross 5 matrix. Fine. So that's all are my 1. So it will be 5. So that option is cancelled. Can you find the determinant of trace of the A raised to power 5, which is also 5? That option is cancelled. Fine. Now these two options are correct based on A is equal to I. Now look at the second case. If you consider A is equal to minus I, A inverse is also minus I. Characteristics are same. Now what is the A square? Is plus I. A raised to power 5 is minus I. So if you find the determinant of the A square is a 1, if you find the determinant of the A raised to power minus A raised to power 5, it is my minus 1. So this option is cancelled. Only left option is A is my right answer. Always consider students this 0, I and minus I is the right the way. हमेशा ये सिर्फ पहले ये 3 मैट्रिक्स को चूज करिए जिससे आप अपने ऑप्शंस को डिस्कार्ड कर सको. जो बाकी बचेगा पीछे उसके बारे में बाद में सोचेंगे. Okay, look at this another one. For every positive integer n is greater than 2, greater than equal to 2. तो मैं एक आसान ले लेता हूं n की वैल्यू 2. A is an n cross n matrix such that A raised to power 4, because n is my 2, has rank 0. Fine. That इसका क्या मतलब हुआ? Rank of the any matrix 0. That means A raised to power 4 is 0. That means A is my nilpotent matrix. Is it fine? Now 0 is the 2 cross 2 matrix. Which of the following equivalent to the statements they have n linearly independent vectors? If A has n linearly independent vectors, that means A is my diagonalizable. Fine. Now you must remember this simple shortcut tricks. Nilpotent matrix plus diagonal matrix if and only if A is my zero matrix. Fine. So now you can see A is my nilpotent, A is my diagonal matrix if and only if A is my zero matrix is the right answer of the problem. Okay, look at this another one. A is my n cross n matrix. Okay, your target is to find the dimension. V is the vector space consists of all those collection of the n cross n such that Ax is equal to 0. Very simple. Fine, I will tell you the shortcut tricks. Always remember, you can watch my this lecture only, dimension of the vector space. This is for the gate and this is for the JAM as well as gate examination, both are there. Now, how you can find the dimensions? Always remember, dimension formula, the shortcut tricks is number of the column vectors of the X into nullity of A. That's all. Fine. Or you can say n. How you can find the nullity? By using the rank nullity theorem. Number of the column vectors are my n minus rank of the A. And what is the rank of the A's? R. That is the right answer of this problem. Fine. You must watch about my this lecture dimension of the vector space. Only dimension of the vector space you will get the shortcut tricks in a simple manner. Before I move on the next questions, there are so many questions are there. I hope you have changed your thinking from the oof to wow based on all these explanations or shortcut tricks. Please like and comment on the video as well. Again, I can choose n is my 2 for the easy case so that A and A square has the same rank. If both have the same rank, that means nullity of the A and nullity of the A square is also same. Consider the transformation from, if I take R2 to R2 defined by T of V is AV. Then the kernel of the T. Kernel of T means that is A. Fine. You can define as in terms of the nullity. That is a dimension of the nullity. T circle T. What is the T circle T of V? It will be T of AV. This will be A square V. By using what is the T of V? T of V is my AV. And again, this is my V. Then A into A. That is A square. So basically, T circle T is like A square. So that means kernel of T is same as kernel of the T circle T because of nullity of A and nullity of A square are same. So yes, this is the right answer. Once the kernel are same, so definitely they are of the same dimensions. A must be invertible. A must be invertible. So can you think any of the example whose rank are same? You can see. Fine. A square is again same. So rank are same. Fine. But you can see this is not invertible. Fine. Or you can consider this example 0, I, minus I. Fine. Like I plus A. If I consider A is equal to minus of I, then A square will be I. Clearly say the rank of A, rank of the A square are same. Both are my 2. But what is the I plus A? I plus A is a 0 and it must be invertible. That's the wrong option. So A and B are my right answer of this problem. You can see that these are the very funny cartoons. That's why I'm put up here because this question is a very funny question. Okay, again you can see I can choose n is my 2. No, n is greater than equal to 3. So I can choose n is equal to 3. Fine. So can you write the matrix A? A will be my 3 cross 3 matrix. Your target is to find the eigenvalue. A11, that is a product. 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Your target is to find the eigenvalue. How you can find the eigenvalue? You can see that I can find the determinants, or I can write 1, 2, 3. I can use R2 minus 2R1, 0, 0, 0, and R3 minus 3R1, 0, 0, 0. What is the rank? Because whenever you will see the question related to the matrix, try to solve either with the help of the eigenvalue or with the help of the rank. So rank is my 1. That means out of the 3 eigenvalues, 2 must be 0. Fine. And can you find the third eigenvalue? Third eigenvalue you can find from the trace. So what is a trace? Trace is my 14. Now look at the options. 1 cancel. N is my 3 because I need a 14 answer. Is a 3, 4 by 2. That's option. Only left behind is here. You can check about that. 3, 4, 3 to the 6 into 7 divided by 6 is 14. So fourth option is the correct answer. Okay, which of the following is my positive definite? Positive definite. What is the condition for the positive definite? Determinant should be greater than 0. Can you find the determinant? 2a minus 1 minus of a 0 must be greater than 0. So that will be 4a minus a, 3a minus 2 greater than 0. A will be greater than of 2 by 3. Fine. Now a is a positive definite for all a less than 3. A belongs to the R. That's wrong. Why? Because if you choose a is equal to 0, then it is not satisfied. A is a positive definite for all a greater than 3. That's true. Because this is my 2 by 3 is a positive definite for all those values of this. And for the 3 greater than, it is also satisfied. Yes. A is a positive definite for all a greater than of minus 2. Again wrong. If you choose a is equal to 0, 0 is not satisfied here. A is positive definite only for finitely many values. That's wrong because the interval is infinity. So that means it says infinitely many value, but he said finitely many value. So the right answer is B is the correct options. You can see the students, it's a 2023. This is a 2023. How easy are they based on my lectures? Can you look at this next one? Again, it's a December 2023. Again, N is not given to you. A is my 3 cross 2. B is my 2 cross 3 such that BA is my identity. Okay. Then AB is equal to I3. That's the statement. Always remember that. In this previous lecture of the real analysis, what I told you, if F is a mapping from X to Y, G is the mapping from Y to X, such that F circle G is my identity. Fine. Then this is my 1 1. This must be on 2. Fine. Or because the same mapping here. Fine. The same thing here. Otherwise, I will consider about the rank. Can you find the rank of the A? It is less than of the minimum. Can you find the rank of the B? It is less than of the minimum. Now, can you find the rank of the AB? It must be identity, so it must be the 3. Also, rank of the AB is less than equal to minimum of rank of A, rank of B. So can you find the minimum of this? Less than 2. Is it possible? No, because 3 can never be less than equal to 2. That is cancelled. Now, A is the real matrix. Then there exists a matrix B with the integer entries such that AB is equal to identity. The most important word here is integer entries. Always remember, student, the matrix A has inverse exist in integer. Fine. Only if determinant of A is plus minus 1. अगर मैट्रिक्स कोई भी मैट्रिक्स हो, अगर आपको उसका इनवर्स इंटीजर में चाहिए, फाइन, वो तभी पॉसिबल है जब डिटर्मिनेंट ऑफ मैट्रिक्स प्लस माइनस 1 होगा. फाइन. इस केस में देखते हैं इसका डिटर्मिनेंट कितना आ रहा है, 6 minus 3 which is 3 not equal to plus minus 1. so इसका मैट्रिक्स B का इनवर्स कभी भी इंटीजर, B की वैल्यू जो इंटीजर नहीं आएगी. फाइन. Look at the third. Then there is a Z6. What is the value of the Z6? Z6 consists of, fine. Now again ये आपका क्या है, this is again the integers. और फिर से आपको क्या पूछा है, इनवर्स, बिकॉज AB is equal to I. Your target is to find the value of B. So इनवर्स कब एग्जिस्ट करेगा, जब ये कंडीशन सेटिस्फाइड होगी. So can you find the determinant of this? 6 minus 1, 5. How I can write the 5 in terms of the Z6 minus 1, and that satisfied this property. Yes, it is correct statement. Okay, look at A is a non-zero 3 cross 3 diagonal matrix. A is a non-zero. Can you write the non-zeros? I can choose this value. Then there exists a matrix B, so that B has a inverse B. What is the rank of the A? 1. Can you find the rank of the AB, which is always be less than of the minimum of rank of A and rank of B. Now whatever the rank of the B, fine, it always be less than equal to 1, but it can never be 3. So you can see 3 can never be less than 1. So this option is also cancelled out. So the right option is only C is my correct answer. Which of the following statement is my false? Again, they are talking about the matrix. So you can talk about either the eigenvalues or the rank. Since they are talking about the rank, so we will see the rank. What is product of the two eigenvalues? So if I say rank of the A, rank of the B, this is given to you. Your target is to check whether the rank of AB is equal to 2 or not. Fine. What is the property of the rank? You must watch about my this lecture, rank of the matrix. Fine. अगर आपने अभी तक नहीं देखा, you must watch it. Definitely you will learn a lot. What is the rank of the AB? It must be less than of the rank of A, rank of the B, and what is the rank of the AB? It is also greater than of the rank of A plus rank of the B minus what is number of the column vectors of the AB. What is the rank? If A is my 2 cross 2, B is my 2 cross 2, then AB is also 2 cross 2. Then this must be N. What is the N? N is the number of the column vectors. So that is my 2. Fine. Now I can substitute these values. So what is the rank of the A? 2. Rank of B 2. So therefore rank of the AB is less than equal to 2. From the second case, rank of the AB is greater than equal to 2 plus 2 minus 2, that is 2. So from these two cases we can say the rank of the AB is 2. So this is my correct statement, but we need a false statement. Look at the second one. Product of the 3 2 cross 2 matrix of rank 3 is at most 2. So again, rank of the AB is less than equal to 2 by using this. Rank of AB is greater than equal to 2 plus 2 minus number of the columns. Can you find that AB dimension? AB matrix is 3 cross 3. Number of the columns are my 3. So this implies 4 minus 1. This will be AB is less than equal to 2. So what you can rank is at most 2. Yes, this is at most 2. So this statement is also correct statement. The product of the two 3 cross 3 matrix of the rank 2 is at least 2. This is my at least, but this is at least 1. So that statement is my false statement. Product of the two 2 cross 2 matrix of the rank 1. What is the meaning of this? Rank of the A, rank of the B is my 1, and your target is to find the rank of AB. It is less than equal to rank of minimum of this, and it is greater than equal to 1 plus 1 minus number of the column vectors. So what will happen is a 0 less than of AB is less than equal to 1. So it can be zero matrix. Yes, it can be zero matrix. So the first is a true statement, this is a false statement, so only the C is my right answer of this problem. Okay, look at this another one. Consider again the matrix is given to you. Fine. Either you can find eigenvalues or by rank. So firstly we can see A is invertible or not. Firstly, can you find the rank of the matrix? You can see that I can write this form. Fine. So always remember 0 1 1 0. Fine. Okay, firstly I can give you the small tips. Whenever you have this matrix, then the eigenvalues are always plus minus root AB. Fine. So in this case, can you find the eigenvalues of this? It's a plus minus A into B. So you have the 4 eigenvalues. First eigenvalue is 1, second value is minus 1. Can you find the eigenvalues of this? Each row has the sum 2 and the trace is also 2, so other values are 0. Fine. So therefore, eigenvalues of the A matrix is minus 1, 1, 2, 0. So can you say A is invertible? Because determinant is my 0. You can see that determinant is my 0. Why? Because one eigenvalue is 0. So this option is cancelled. Eigenvalue of the A square 1140. Eigenvalue of the A square is my positive, but you can see 0 is also present. This option cancelled. There exists a non-zero vector V and W such that V comma W must be 0. V comma W must be 0 means V transpose this will be 0. This is possible only if A is your indefinite matrix. Fine. So how you can check about the indefinite matrix? When the eigenvalues are positive and negative, and you can see yes, the eigenvalues are negative and positive both. So yes, this option is the correct option. Now look at the third option. V is not okay. Your target is to find V is not equal to U and W, provided V is not equal to W. Fine. For all the non-zero vectors, I can choose the easiest one. Fine. This is my easiest one. Now I can find the left hand side. It will be V transpose. So what is the transpose of this? 1 0 0 0, because I have to multiply them, so that's why I am written here. Fine. This is my 1 0 0 0, then matrix, and then W. So it's a W1 V1 V2 V3. So that is my V1 V2 V3 V4. Now if you multiply them, it will be V2 0 0 0. So that will be only V2. V2 means second component. So now you can see. So similarly, if you consider this case, it will be my W2 because for the fixed value. Now you can see if I choose the value of, fine, this is a non-zero. This is my 1 1 0 3. Fine. V is not equal to, but you can see the second component I have fixed them. So that means they are same. Whenever V is not equal to W, these two values are same, but he said not equal to. So that option is also cancelled. Only one option, that is a B, is my right answer of this problem. Okay, look at this another one. Again is a matrix. So look at the eigens value. 6 is one of the eigenvalue. Fine. 6 is one of the eigenvalue. So how you can write that? 2 एक possible case हो सकता है. Fine. So if you compare them, I consider A is my 0, B is my 0, C is my 6. Fine. Now look at that. AB is equal to 0, satisfied. C is satisfied. A plus B is 8. Cancel. 24 minus 0 is 24, satisfied. Fine. But you आप correct नहीं कर सकते. This is one of the counter example. Now, और कैसे बना सकते हो आप second example? 6 is one of the eigenvalues. So if each row has a sum 6, then it has, fine, हर रो का सम मिल गया आपको 6, तो 6 आइगन वैल्यू होगी इसकी. नाउ यू कैन सी दैट a is equal to 4, b is equal to 6, c is equal to 0. So c is equal to 6, cancel. ab is equal to 0, cancel. Look at this case. 24 minus 24 is 0. Only one option left, which is satisfied. A is my right answer. And you can see it's a very recent year paper and the same concept I have used. V is a 2 cross 2 matrix with the entries. V is my here. Fine. V is my 2 cross 2 matrix. Can you find the dimension of this V? Dimension is 4. 2 cross 2. This is also 4. So therefore, capital T is my 4 cross 4 matrix. So the characteristics polynomial of the capital T is also of the 4 degree. Fine. So first option, cancel. Can you find the eigenvalues of this? Eigenvalue are 2 and 1. So can you find the characteristics equation directly? It will be 2 of identity and it is 1 of identity. And what is the size of this identity? It's a 2 cross 2 matrix. Fine. So now what is your capital T? It will be 2002 and 1001. Rest values are my 0. Fine. Now can you find the eigenvalues? Eigenvalues are 1 1. So what is the characteristics equation? Fine. So C is my right answer. Rest options are cancelled. Hardly 5 seconds you are needed be. Please like and comment on the video as well. Okay, V is the subspace spanned by the vectors. Which are the following vector in the V? Okay, that means alpha 1, you have to multiply the first vector by alpha 1, second vector by alpha 2, and third vector by alpha 3. And then see for the real values of the alpha I, can you form this matrix? Can you form this element? Clearly say the second element is my 1, but here the second element is my 0. So it can never be formed. Fine. Now, can you write the equation? So if it is the second one, alpha 1, 2 times alpha 1 plus alpha 2, 3 times alpha 1, 3 times alpha 2, and alpha 1 plus 5 alpha 2 plus alpha 3. That is first component, second component, third component, fourth component. Fine. Now, if it is the second part, it will be 0, it will be 0, it will be 1. Sorry, second component is a 0 already. It's a third component 1. This is my 2, this is my 4. Can you find the value of alpha beta? Alpha 1, alpha 2. Alpha 1 is a 0. From this case, alpha 2 is my 1. Is it satisfied this condition? No. So that means this option is cancelled. Now look at the third option. For the third option, this is the first component, then 1, 0, 1. So let's see, can you find the value of alpha 1? Alpha 1 is 1. If you substitute here, alpha 2 is my minus 1. Is it satisfied? Yes, satisfied. This is 1 minus 5 plus alpha 3 is equal to 1. So alpha 3 you can get as a 5. So yes, you can obtain the values of the alpha unique values. So this option is the correct option. Now look for the part 4. So you can put right hand side as a first number is 1. This is the third component 1. Is a 0. is 2. Again check whether you are able to find the value of alpha 1, alpha 2. It is again -1. This is satisfied. Again from this case you can find the value of alpha 3 as well. Fine. So yes, you can find the unique values. So this option is also correct. C and D are my correct options. You can see that within a couple of seconds you can solve the recent year papers as well. Okay, now this is the linear transformations. Fine, because in this lecture I have considered very few questions related to the topic wise, but for more details, like for the rank, you can watch this system of the equation this, and for the linear transformation rank nullity theorem, you can watch about this state problem. Capital T is the mapping from the P2 to P3, which are defined like T of fx is integration f plus derivative. Fine. Now, then the matrix representation. Very simple. Can you find the dimension of the P2? Dimension of the P2 is my 3. Dimension of the P3 is my 4. P is my polynomial. Fine. Always remember the dimension of the polynomial of degree n is n plus 1. So that means this matrix T is of dimension. What is the dimension of this is 4. So will be 4 cross dimension of P2. So the answer will be 4 cross 3. Firstly look about the option. This is my 3 cross 4. Cancel. 3 cross 4. Cancel. This is 4 cross 3. Fine. This is 4 cross 3. Fine. Now look at the basis of the P2. What are the basis of the P2 is polynomial of degree 2, 1, x and x square. Substitute x, f is my 1. Firstly taken as a 1. So integration of the 1 is plus derivative of 1. Integration of the 1 from 0 to x. It is my x. Fine. So I can write here is this is my polynomial 1 x and x square. This is my x cube. Now answer is x. Coefficient of the x is 1. So this one is my 1. There is no other terms. That's are my 0. Similarly, now you can look at the x. Substitute here. Integration of the x will be x square by 2 plus derivative of the x is my 1. So that's a 1 is constant. X square, coefficient of the x square is half. Rest terms are 0. Now you can see that 1, 0, half 0. It is a half 2. So this option cancel. Only left option is B is my right answer. Look at this another one. V is the vector space of the polynomial R, which is of less than or equal to n. Choose n is my 1. It's quite easy. So V is a polynomial of degree less than equal to 1. So what is the dimension? Dimension is 2. Fine. Then your Px will be A0 plus A1 x. T is a transformation from V to V. Fine. So can you find the matrix size? V has a dimension 2. So it will be 2. It is 2. Fine. This is my matrix T. Such that T of Px will be n is my 1. So it's a A1 plus A0 x. Fine. Now can you find this? So take the basis of the polynomial of degree 1. What are the bases? 1 and x. So if I substitute, find the value at the 1. First basis T of 1. But 1 is a constant. So there is a 1 plus 0 x. So that's a 1 and 0. Is it okay? Now sorry, px is sorry, fine. Px is my 1. So you can compare them. That means A0 is my 1, A1 is my 0. So this number will be A1 is my 0 plus 1x. Fine, this is my 1, this is my x. So constant is 0, coefficient of the x is 1. Second case, when you consider the second polynomial x, again compare with the help of the px. A0 is my 0, A1 will be my 1. So this is a 1 plus 0x, 1, 0x. Fine. Now when it is a 1 1, if the rank of the matrix is the number of the column vectors, then it is a 1 1. If Okay, firstly I will tell you the shortcut tips that could be easy. If T is the mapping from the V to V, then T is said to be 1 1 if and only if T is onto, provided dimension of the V and V must be same. फाइन, अगर ये दोनों सेम डायमेंशन के हैं तो 1 1 एंड ऑन टू सेम होगा, जैसे 1 1 है वैसे ही ऑन टू भी होगा. लेकिन अगर ये V से W है, then this result is may or may not be true. Fine. Now you can see that. Can you find the rank of this matrix? Rank is my 2. Nullity of the transpose. Can you find the nullity? Rank minus. Fine. So rank is the number of the column vectors. Column is my 2. So yes, T is my 1 1. So if T is my 1 1, T is a mapping from the same to same. T is also on 2. T is invertible. Determinant is my -1. Determinant is my plus minus 1. Is that determinant is plus minus 1 or only the plus 1? You can see the determinant of the T 0 minus 1. So but it's a plus minus 1. So only the plus 1 is the, so A, B and C are my right answer of this problem. Okay, T, V is the vector space of the dimension V. T again you can see the same to same, so it's a 3 cross 3. Fine. Capital T is my 3 cross 3. With respect to the order basis, so that's a standard basis. I can choose V1 is a standard basis. Fine. Which of the following statements are my true? What is the T of V3? This is my V3. Fine. This is my T of V3, which is my non-zero. V1 plus V2. What is a V1 plus V2? This is my V1 plus V2. Do you get a sum 0? This is a 0. This is the -3. So that means this is my non-zero. Sum of them will be 0. Can you find the sum is a 0? 0 is a 0 is a 0. Yes, this is a correct statement. V1 plus V3 is must be V2. V1 plus V3. Will it be equal to the V2? 1 plus 0 is -1. Not satisfied. C is my right answer. Okay, V is the vector space of the polynomial of degree less than 3. Fine, but I need a equality always. So I can say this is less than equal to 2. Can you find that? Okay, which of the following statements are? So what is the dimension of this V? Can you find the dimension of the V? Now, it's a 2 variable. How you can find the dimension of the 2 variable? Always remember this formula. Fine. What is the n? N is the polynomial of degree less than equal to n. If you compare them, it must be the equality. So in this case, n is my 2. VAR is a variable. How many variables are there? There are the 2 variables. Fine. So if you substitute here 4C2, 4C2 means 6. Fine. So that means this has a 6th dimension. This also has the 6th dimension. So your matrix will be of 6 cross 6. And what are the bases of this? 1, x, x square, y, y square, xy. Is it fine? Now you can check about the options. How you can solve the problem? Let me clear this. Now firstly you can find the polynomial is 1. F is 1. What is the partial derivative with respect to x is 0. So constant is 0, x is 0, all are my 0. Then if I consider f is x, what is the partial derivative is 1. 1 is my constant, so 1, rest all are my 0. Second is x square. What is the derivative of the x square is 2x. That is a coefficient of the x is my 2, rest are my 0. Y. What is the partial derivative with respect to y? 0. So 0 is all are my zeros. Similarly, y square is a 0. Xy, what is the partial derivative of x y with respect to x is a y, coefficient of 1, rest all are my zeros. Fine, this is my matrix T. Now let's give the answers. Nullity of the T. So can you find the rank of the T? So clearly say 1 row, 2 row, 3 rows are my 0. So the rank of the nullity is 3. Nullity is my 6 minus 3. So nullity is at least 3. Yes, equality appears. Nullity at least appear, equality appears. That's a correct statement. Rank is at least 4, greater than equal to 4, but rank is 3. So that option cancel. Rank is at least 3. Yes, equality appears. T is invertible, wrong, because because the rank is less than 3 and 0 is the one of the eigenvalue. So the determinant of T is 0, so T is not invertible. So that is answers are A and C are my correct answer of this problem. Okay, again V is a polynomial of degree at most 10 and T is, what is the mapping? Degree is at most 10. Fine. So what is the dimension is 11? So it will be 11 cross 11. So can you write the polynomial of 11 cross 1 x square up to x of 10? Is it fine? Now you can see it's a derivative. What is the first derivative? 0. So all the values are my 0. X derivative is my 1. Rest values are my 0. X square derivative is 2x. Coefficient of the x is my 2. Rest values are my 0. X cube is 3x square. So that number is my 3. Rest values are my 0. And similarly for the x10, the coefficient is x raised to power 9. So this will be 9. Rest all values are my 0. Fine. Now clearly say the diagonal entries are my 0. Fine. And you can see it's the last row is also 0. This is my matrix. So determinant of the matrix is 0. And rank of the matrix is my 10 because it has a last non-zero elements. Trace some of the diagonal entries. Determinant 0. All eigenvalues are 0. Yes, correct. All are my correct options of this problem. Okay, look at this another one. T is a mapping on the R cube, F is a characteristics polynomial, and so on. Suppose T is my non-zero and 0 is 1 and 1 eigenvalue is my 0. You have the 3 eigenvalues, 1 eigenvalue is 0. What about the other eigenvalues? I can choose alpha 1 and alpha 2. Fine. So can you write the characteristics equation? X minus 0, x minus alpha 1, x minus alpha 2. Fine. So this is my fx. Fx is x into x minus alpha 1, x minus alpha 2. So then 0 such that x of gx. So can you find the value of the gx? It will be x minus alpha 1, x minus alpha 2. Then the g of t is also 0. But what about the alpha 1? It can be any numbers. So let's choose alpha 1 is 1, alpha 2 is my minus 1. Fine. So this number will be my x square minus 1. So g of t, it will be my t square minus identity. Fine. So what are the eigenvalues of the t? One eigenvalue is 0, other eigenvalue is 1, third is minus 1. Can you find the eigenvalue of the t square? 0, 1, 1. Fine. Now can you find the eigenvalue of the t square minus I? It will be minus 1, 0, 0. Fine. So g of t will be like minus 1, 0, 0. Rest values are my 0. And is it a 0 matrix? They are not 0. So that statement is my false statement. So that statement is false. That means first and third options are cancelled out. Fine. Now Look at the second options. 0 is the eigenvalues with at least two linearly independent eigenvectors. That means geometric multiplicity is my 2. So that is 0 and 0. Is it fine? No, that is at least 2. That is a geometric multiplicity of the eigenvalue is my 2. Is it fine? Geometric multiplicity of the eigenvalue 0 is my 2. So can you find the algebraic multiplicity? Fine. That means algebraic multiplicity is either 2 or algebraic multiplicity is either 3. Fine. If algebraic multiplicity of the eigenvalue 0 is 2, that means there are the 2 0 eigenvalues and say one eigenvalue is alpha. Is it fine? Then can you find the characteristics equation? It will be x square, x minus alpha. This is my fx. Now if you compare them, what is my gx? Gx will be x into x minus alpha. Fine. Now can you find the eigenvalues of the t? This will be 0, 0, alpha. I need x square minus alpha x. Eigenvalue of the alpha into t is 0, 0, alpha square. Eigenvalue of the t square is 0, 0. So if you subtract them, g of t will be 0. So for this case, g is also 0 satisfied. Now look at this case. If algebraic multiplicity of the 0 is 3, what does the meaning of that? Can you tell me? That means it is a nilpotent matrix. Once is a nilpotent matrix, the characteristics equation is x cube is x cube. So then your gx will be my x square, and once is a nilpotent matrix, it is also 0. So in both the cases, we will get as g of t is my 0. So this is my correct statement. So only second is my right answer of the problem. Okay, look at this another one. B is my 3 cross B. So the rank of the B is less than equal to minimum of 3 and 5. Suppose collection of all those elements such that is 0. What does it mean? Once is a 0, that means it's a nullity. So can you find the nullity of B? Yes. Anybody? How you can find the nullity of the B? So it is 3. Fine. Because it is given that it's a 3 dimension. So if nullity of the B is 3, can you find the rank of the B? Number of the column vectors minus nullity. Rank is my 2. Then if the rank of the matrix B is my 2, what does it mean? Column span is my 2 dimension. Fine. Look at this case. It is a 1, 1. We can find the rank. We all know the rank of the B into B transpose is same as of the rank of the B. Fine. And the rank of the B we have obtained as the 2. Fine. Which is not equal to the number of the column vector. Column vectors, what is the size of this matrix? 3 cross 3. So which is not equal to the number of the domains. That means it is not 1, 1. So it is injective, not possible. Again, here is they are talking about the injective. So can you find the rank of the B transpose? Rank of the B transpose is same as the rank of the B, which is same as 2. It is again not equal to the number of the column. So that means this is again not 1, 1. So this option is also cancelled out. Now, the only difference here is elements of the V is from R and this is from Q. But from where the elements came, that nullity or the dimension is remain the same. So that means nullity of the B is still 3. So A is the correct option, C is the correct option, is the right answer of the problem. चलिए अगला देखते हैं. P of 10 is the polynomial of degree 10. Can you find the dimension of the P10? This is my 11. This is my V. W1 is a polynomial. of degree up to the 5, collection of all those polynomials of degree 5. W2 is the subspace of all those polynomials from where polynomial of the F10 such that sum of the coefficient is my 0. That means P of 1 is 0. Fine. Sum of the coefficient means when you substitute the coefficient of the x are 0. Can you find the dimension of the W1? What is the dimension of the P5? 6. Can you find the dimension of the W2? It's a 11. There is one additional condition, it's a -1. Fine. Then dimension of the intersection. Can you find the intersection? It will be, what is the intersection of P5 and P10? It's a P5 such that P of 1 will be 0. Now can you find the dimension of intersection? Dimension of P5 is 6 minus 1 condition is 5. So that's, yes, it's a equality appears. So the dimension of the is at most 5 is the final. Fine. Now W1 contained in the W2. W1, pick any element from the W5 or W1, say x cube. X cube belongs to the W1. Does it also belong to the W2? No, because W2 consists of only those elements whose coefficient is my 0. When you substitute 1, it's not 0. That means W1 does not contain in W2. Fine. Now W is equal to V. V is my P10. So when it will be the same, when dimension of the W is same as dimension of the V, which is 11. But what is the W? W is the smallest subspace. So let me clear this. What is the smallest subspace? We all know it's a W1 plus W2. Fine. Now how you can find the dimension of the sum? It will be dimension of W1, dimension of W2 minus dimension of intersection. Now if you substitute the value of dimension of W1, I rub that. Dimension of W1 is my 6, dimension of the W2 is 11 minus 1 is a 10, dimension of the intersection we obtained as 5, so that will be 11. So which is same as dimension of the V. So yes, they are same. Dimension of W is at most 10. This is less than equal to 10, but we have obtained the 11. So that option is cancelled. B and D are the right answer of the problem. Okay, I think it's too much questions in this video. We will upload the next video very soon on the part B. Till then, you must watch about this playlist and revise the last minute's shortcut tips through these videos. Let me know in the comment box whether these videos are helpful for you. Till then, you can share these videos and don't forget to subscribe my channel. Best of luck, students. Happy learning.